let's say that we wanted to solve this quadratic equation. 4x squared minus 3 equals 0. Now, is this going to be something that I can factor? No, right? Not using the techniques that we've talked about so far. However, notice here on my left-hand side, I have only x squareds. There's no plain x term on that left-hand side. Does everybody see that? Do we understand what I mean by a plain x? Okay. So what I can do instead is I can solve this directly. What do I mean by solve this directly? Well, I can add 3 to both sides. Bless you. And then divide both sides by 4. And then square root both sides to cancel the x squared. And when I square root both sides of an equation like this, what do I have to remember? That I get a plus or minus? So we get that plus or minus anytime we square root both sides of an equation. Everybody okay with that? Does that ring a bell? Okay. So, how do I take the square root of a fraction? I'm taking the square root of 3/4 there. How do I square root a fraction? Yeah. Right? Like over here, this says the square root of 3/4. How do I square root a fraction? You don't put in your calculator. Yeah, we just take the square root of the top and then the square root of the bottom. Now the square root of 3 is a decimal. I'm not interested in that. I'm just going to leave it as the square root of 3. But the square root of 4 is 2. Everybody okay with that? Does that feel okay? What if we instead have something like this, where we've written it in like this kind of vertex form? And I want to solve this for x. What can I do here? Well, If I look at the left-hand side, how many kinds of x's do you see? I see only one kind of x, right? What does that tell me? Well, I can solve this directly, just like the last one. Yeah, I wouldn't want to try to factor this. It may or may not factor if I multiplied this all out. But that seems like an awful lot of work for something that I can, in its current state, just try to solve directly. So let's do that. So what would I want to do first if I were to try to solve this directly? Anyone with an idea? Dan? So you're talking, you want to do this? Is that what you're saying? Well, we can't do that because it would be violating the order of operations. I can't multiply that 3 in before I've taken care of that exponent. But if we're trying to solve, I wouldn't want to do that anyways. In general, when I'm solving directly, you remember the order of operations? Please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. When we simplify, we're going this direction. When we're solving, we're undoing it, any simplification, so we're really starting at the opposite end. So the first thing I want to do in a solving problem is undo any addition or subtraction. Well, I have a minus 6 at the end of this, so let's start by undoing the minus 6. So I can just add 6 to both sides. Everybody okay with that? Now I see also that minus 5, but the minus 5 is inside the parentheses, so I'm not going to get to that until I get to the p. So I'm going to skip the minus 5 for now. Is everybody okay with why we're not dealing with that right away? What should I deal with next then? I see some multiplication. I should deal with that before I get to the exponent. Again, because I'm solving, I'm going from right to left. So how am I going to get rid of this times 3? And just divide by 3. And now it's time for the exponent. How am I going to get rid of that squared? Yeah, I'll just take the square root of both sides. Everybody okay with that? Now, when I take the square root of both sides like that, what do I have to remember? The plus or minus. And the square root of 2 is just a decimal, so I'm not interested in decimals. I'm just going to leave it as the square root of 2. Is everybody okay with what we've done here? And my last step then would be to just add the 5 over. Now, can I add 5 directly to the square root of 2? No. So how should I write this? I'm just going to write 5 plus or minus the square root of 2. I'm going to kind of treat that square root of 2 like I would a variable. So like 5 plus x is x plus 5. 5 plus the square root of 2 is 5 plus the square root of 2. Everybody okay with this? Does anybody see anything as an immediate consequence of this? Okay, let's ask a different question then. So we've seen that when I have something in this kind of vertex-ish form, at least in this case, I could solve this directly. Would there be a situation where I have a problem set up like this that I couldn't solve it directly? Nicholas?
If you added the number to 0, it might not divide out properly.
So you're talking about like at this step, right? Well, if the number doesn't divide and we're left with a fraction, we can still square root a fraction on the next step. So that's probably still going to be okay, although the problem becomes a bit messier. But we can still get a numeric answer to that, right? So that's a good idea, and a possible, like, the problem gets a little bit harder, but I don't think it prevents us from using this method. So the takeaway here is that this solving directly method works every single time, provided that we have something in this vertex form, right? Now, do we know how to take any polynomial and put it into this vertex form? Do we know how to take any quadratic and write it so it looks like it's in vertex form? Yes. We spent like a week talking about how to transform in between intercept form, standard form, and vertex form. The catch here is, though, that if I were given something in standard form, and I want to write it in vertex form, I have to use the completing the square process. However, that completing the square process, that's the same every single time, right? So if I can do this, the completing the square process once, very generically, for a standard form polynomial, and then solve that, I'll have myself a formula that I can use to get around that completing the square process. So let's do that. So for this part here, I'm going to do this. What I'm about to do is not something I'd expect that you have to repeat. All I want to do is kind of show you what this process looks like. So you can take notes on it if you wish. But if you just want to kind of pay attention and follow along, that's okay too. There's a lot of symbols kind of rattling around. And we'll kind of tie this back together and show you why this was so useful and so important in a few moments, just to give everybody a heads up so that we don't get like too flustered and overwhelmed, okay, because it is a little symbol-y because there's a lot of stuff rattling around. But we'll tie this all back together here in a moment. All right. So I want to take ax squared plus bx plus c equal to 0. And I want to do CTS on this to get something that looks like this. And then I want to solve this, and my result's going to be some kind of formula. Okay? That's just kind of an outline about what I'm about to do. So the first step to the completing the square process is I need to make the leading coefficient equal to 1. Right now my leading coefficient is equal to b. So what should I do to make this leading coefficient equal to 1? I'm going to divide both sides by a. The next thing we do is we're going to move that constant term over to the other side. Everybody okay with that? Now comes the completing the square process, where I'm going to add this b over a divided by 2 squared to the both sides. With that. Now, if we remember the completing the square process, this piece factors. It's going to look like something plus something. This first something comes from here. My second something comes from here. And then I'm going to go ahead and multiply this piece out. So when I square a fraction, I square the top, and I square the bottom. So b squared is b squared. 2a squared is 2 squared times a squared, or 4a squared. And now what I'm going to do is make a common denominator here, so I can combine these fractions into one thing. If I look at these, what would the common denominator be for these two fractions? 4a squared. squared. So to make that common denominator, I just need to multiply this one by 4a over 4a. Everybody okay with that? So now we have something that kind of looks like it's in vertex form, where I've already moved the constant over to the other side. So let's now start solving this. Notice that I have just one kind of x there on the left-hand side. So I can square root both sides now. And then again, remember to square root a fraction, or when we square root both sides, we get a plus or minus. To square root a fraction, I can square root the numerator. Well, there's nothing to do up there. But when I square root the denominator, the square root of 4 is 2, and the square root of a squared is a. And again, we're solving now, so the last thing I want to do is get that x by itself. So I'll subtract b over 2a from both sides. So notice here that this fraction and this fraction have a common denominator already. That common denominator is 2a. So I'm just going to write this all as one big fraction. Grace? Can somebody answer that? No. Right, we started this by stating that this was a process I would not expect you to be able to repeat. Which gives us this result. Does anybody recognize this? Yeah. This has a name, does it not? This is called the quadratic formula. And what it says is that for ax squared plus bx plus c equal to 0, the solutions for x are x equals negative b plus or minus b squared minus 4ac all over 2a. So what we have now is a tool that we can use all the time. The only requirement to be able to use the quadratic formula is that we have a standard form polynomial. If you remember back the process to get the standard form polynomial, to go from intercept form, all you had to do is FOIL. That was an easy process. And to get a standard form polynomial from vertex form, all we had to do was expand. That was an easy process. And so really, any way we've written our quadratic, we can convert it into this standard form and use this formula, and it will always work. So let's see some examples here. So this is a standard form polynomial, right? So I could apply the quadratic formula to this. Let's start by identifying the values for a, for b, and for c that I'm going to plug into my formula. What is the value for a? 1. What is the value for b? 9. And the value for C is negative 36. So what I can say then is x equals negative b plus or minus square root b squared minus 4ac all over 2 times a. Would I expect you to memorize this formula? Yes. The formula, yes. How to get the formula? No, you don't need to repeat that process for me. I just want you to know where the quadratic formula comes from, because those of you that have seen it before find it unlikely that you would have been shown where that's coming from. Okay, so now all I need to do is kind of crunch some numbers. 9 squared is 81. Negative 4 times 1 is negative 4. And then times negative 36 is 144. And that's all over 2. 81 plus 144 is 225. The square root of 225 is 15. And then I'm going to break this into 2 different problems. I'm going to break it into the plus problem, and then I'm going to break it into the minus problem. So I have my 2 answers are 3 and negative 12. Is there an easier way to do this problem, though? Yeah, let's go back and look at the beginning, okay? X squared minus 36, or plus 9x minus 36. Is this factorable? Are there 2 numbers that multiply to give me 36 and add to give me 9? Sure. What are they? Positive 12 and negative 3. Everybody agree with that? And so when I set those equal to 0 and solve, I get negative 12 and positive 3. So factoring, if you're good at it, much faster and easier to use than the quadratic formula. What's the drawback, though, to factoring? Can't use it every time, right? What's the plus for the quadratic formula? I can use it every time, but it's a little bit slower. So, what I am going to do is I'll post an assignment here. Actually, let's do some more practice. We still have a little bit of time. Let's do some more examples. But I will post an assignment that has quadratics that you can solve using a variety of methods. It'll be kind of up to you to pick the best method. Okay? All right. So let's just, we have 15 minutes still left. Let's do some more examples just to kind of hone in on this. So to recap, we have 3 solving techniques that we've talked about: factoring, direct, and then the quadratic formula. The catch here with these 2 is you can't use them all the time, but they're really pretty quick. This you can use all the time, but it's kind of slow. Everybody, does that kind of help rein in here the last couple of days together into one little piece of note? Now let's do some examples. So let's say we have 2x squared minus 6x minus 9 equal to 0. Can we factor this? Well, maybe, but what kind of factoring am I going to have to do for this? To factor this? I'm going to have to do that long method, right, where I have to do the factor by grouping. Is that any faster than using the quadratic formula? No. Why not just use the quadratic formula? Because I'm not positive right yet if this factors or not. If it does factor, I know it's going to be that long method that's not going to be any faster than the quadratic formula. So if I have the choice to use any method I would like, I'm just going to use the quadratic formula here because it's just as fast as my other option. Does that make sense? Could you still try to factor this? Absolutely. Would I mark it wrong if you tried factoring this on a test? No way, Jose. But unless you're asked specifically to use a given method, I would not penalize you for not doing that. All right, but if we're using the quadratic formula, what's the values for A, B, and C here? A is, B is, good, and C is, good. So, plugging it into the quadratic formula. What's the quadratic formula again? Okay.
Plus or minus
Mm-hmm.
B squared
Mm-hmm.
minus 4 times A times C
Mm-hmm.
divided by 3 times
Good. Everybody okay with that? I want to point out to you guys, I see lots of students omitting this part of the division symbol and then getting themselves in trouble. That division symbol goes over everything. So make sure you're drawing it all the way. All right, negative of a negative is a positive. Negative 6 squared is positive 36. Negative 4 times 2 is negative 8. And negative 8 times negative 9 is positive 72. Positive 72 plus 36 is positive 108. The square root of 108 is not a whole number, it's a decimal. So we could leave this as our final answer, or what would be more common is if we simplified the square root of 108 a little bit, because there are some perfect squares inside of 108. Have you guys talked about this in geometry last year when you had to do deal with the the Pythagorean theorem, talking about reducing radicals? Okay. Well, if you haven't, we'll do it right now. So what I'm going to do is I'm just going to look at the prime factorization of 108. So that's 2 and 54. That's 2 and 27. That's 3 and 9. And that's 3 and 3. Everybody okay with that? You remember doing a prime factorization back in elementary or middle school, where you draw these little factor trees? What I'm looking for inside of here are perfect squares. So I notice here is a perfect square, and here is a perfect square. So what I can say is 108 is really 4 times 9 times 3. So here's my 4, here's my 9, and there's my lonesome little 3. Everybody okay with that? The square root of 108 then has to be the square root of 4 times 9 times 3. Well, the square root of 4 is 2. The square root of 9 is 3. And I can't do anything with the square root of 3. And 2 times 3 is 6. So I can really rewrite the square root of 108 as 6 square root of 3. Okay. Now can I reduce this fraction that I have here a little bit? I can. So I notice that each of these are even numbers, right? So if I divide the numerator by 2 and the denominator by 2, I can write this as 6 plus or minus 3 root 3 all over 2. And that's my best answer. I'll say right now, going from here to here, if you do this correctly on the test, that's extra credit. If you're able to do that correctly and completely. We'll spend more time in a later chapter talking about simplifying radicals. But if you have this answer, I would give that full credit still. If you're able to correctly go from that answer to this answer, I would make that extra credit for the test. Does that feel fair? Because that's a whole separate skill that we'll spend a whole chapter kind of hashing out when we talk about radical functions later on. All right. Pointing out to you guys, what was the test to see if something was not factorable? We took the square root of b squared minus 4ac and asked, is that a whole number, right? You guys remember that? Why do you think we're taking the square root of 4ac and worrying about if that's a whole number? Right? The square root of b squared minus 4ac was part of our quadratic formula, and it was the part that could come out to be not a whole number. In the case where it's not a whole number, I can't get whole number solutions, which means that I couldn't break it up into little factors. So that's kind of connecting that idea that we gave to you earlier as a little breadcrumb, that this is really just a direct outcome of the quadratic formula, that little factoring test. Okay. So check that Power School today. I'll have an assignment posted, which will be all solving problems. Some will be factorable. Some would be best that you use, might be factorable, but it might be easier to use the quadratic formula. Some might not be factorable at all. Some might be better used to do the direct solving, but could still be used the quadratic formula on. So it'll be a variety of kind of problems for you guys to kind of sort through. Okay? Oh.